Okay, so we have so far done the model evaluation. Then we have missed one spot. Not missed, the next step is visualization. So an inclusive thought that we can add the visualization inside the evaluation method itself. Okay, so let's see how we can do the visualization part. So for that I need to create a visualization method, right? So like evaluate model, I need visualized model, right? So let's create visualize model, that is def visualize model. So to visualize we need what are all the things we need? We need the prediction, we need the test values, and we need the model, right? And we need the metrics. Okay, so first y test, then the predictions. So we need to send this prediction to visualization, right? And so this visualize model is going to be a common method that will be reused for every other models that we are going to work. So it is better to send the name of the model first. Okay, next we can send in the model we can send the model object, like the loaded model. So from here we can send it to here. Then comes okay, now we need the X test also, right? So X test, then RMSE, R2, all the other things. Okay, then the default save plots equal to false. Now we'll have the subplots. AX is equal to plt dot subplots. So for this I have to import matplotlib dot pyplot as plt. Okay, do we need, okay, done. So plt dot subplots are we need to give the figure size. Okay, so figure size is equal to, let's have 8,6. Okay, so the common visualization for a linear regression is scatter plot, right? So for the scatter plot, the ax dot scatter of, we need y test value and our predictions, right? And the alpha will be, this is the opacity, alpha will be 0.6, color red color. Then the label, we can have predictions. So these are the predicted values, right? Then to show the prediction, then we have to plot the edges, like the minimum and maximum. We need to set the min and max. So y test dot min of comma, this is like setting x and y, minimum and maximum. Okay, so y test dot max of, along with this comma y test dot min of comma y test dot max of. Okay, we have set everything now. Then comes the color, that is contrast blue. Okay, line style. Next the label, this is plotting the ideal prediction line and not the fit line. Okay, this is going to be the ideal prediction line, and this is not a fit line. Okay, so we can name it as ideal prediction line instead of the fit line. Then comes ax dot set title. We have to give the model's name. Okay, then this is a plot, a scatter plot about actual versus predicted. Okay, now font size will be 12. Okay, weight it will be bold. Okay, we have set the title. Now ax dot x label and ax dot y label, right? So x will be our actual temperature and the same font size as our title. Next, this will be our predicted temperature. Okay, let it be. Okay, now I'll close it. Okay, so okay, now we are going to place the metrics, right? So I wish to display the metric value in the plot. So ax, before that we'll prepare the text equal to RMSE, where the RMSE will be to f dot to f. Okay, then in the new line it will be R2, so that will be R2 dot to f. Okay, to know, okay, 2f or 3f is enough. Okay, now we'll set this text ax dot text at 0.05 comma 0.95 borders. There comes the text, and we will transform it with our axis ax dot trans axis. Font size will be 11, then color will be okay, the black text. Next, we are setting the alignment. I'll align it to the top, and I need a bounding box for that. So b box, I'm going to send a dict, that is box style equal to round with padding 0.4 and face color. Okay, face color is light gray. Then comes the alpha, that is 0.5. Let's make sure there is no spelling error. Next comes plt dot tight layout, plt dot show, then plt dot close fig, right? This will be our fig. Okay, I need to, okay, we got RMSE and R2 error while calculating the metrics, right? So I have to catch it, or I have to avoid this unnecessary cut of my flow. So when both are not none, I have to perform this. Okay, otherwise this will not be displayed. Okay, now, so once this is done, our linear model has the attribute coefficient, right? Ours is a linear type model, so it is better to display the coefficient plot also. So we have our coefficient, so coef df will be pd dot data frame, where my feature will be from xtest dot columns, right? And my coefficient will be model dot coef underscore. Okay, from from this dictionary, this will form the data frame, that is our coefficient data frame. Then we are going to sort the coefficient. Coef df dot sort values by the column coefficient. Okay, by the column coefficient. Now then the order will be ascending. Okay, so I'll say this as coef df. Next, plotting it, fig comma ax, which is equal to plt dot subplots, fig size is equal to the same 8 comma 6. Now SNS, okay, we'll have a bar plot from Cbon. Import Cbon as SNS. So we'll have a bar plot for this bar plot. So for data, I will be sending this coef df, right? And I need to send x comma y and ax, and to define, I also want to define the palette, right? X will be my coefficient column, y will be my feature column, x will be my ax. Okay, palette will be a common palette. Where it is. Okay, now we have to set the title, simple title, which will be name of the model first, then coefficient, importance, maybe importance. So the font size 12, we'll go with the same font size. Weight is bold. Okay, now set title, then we have to give a tight layout for it, and we can show the plot and close the fig. Okay, what if I get caught in an error while running this? So we will try to catch the burger. Okay, try, I'll just move one tab. Okay, if I have any error, it will get caught up in exception as E. Okay, where I'll print F as error. Visualization failed. It's not about evaluation failed. Visualization failed for the model, that is linear model. Okay, let's choose that. Okay, no mentioning of linear model. Okay, so this will be the end. Now I need to send these params to visualize model. Instead of calling it separately, I can directly call it from here. Where? We can call it from after calculating the metrics we need to send, right? So now here the visualization. So I'll try visualize the model. So for that I need to send name, y test the same name, thread the same name, model, x test the same name. We all have it here, right? X test, y test, name and model. So model is loaded model. Next RMSE is RMSE, R2 is R2. Okay, and save plots. Fine. This is the way of calling, and if it is success. Okay, the visualization method here. So this will not return anything. This will just plot our two plots. One is our actual versus predicted scatter plot. The other one is the coefficient importance plot. Okay, two things. So let's go and visualize. So now I need to restart the kernel. Let's restart the kernel. I'll directly go and run the metrics. Okay, our previous output was only the metrics. Let's see what happens now. Fine, we got everything, but visualization failed for linear regression. Object has no attribute X label. Okay, let's go and find out. Here, where is the X label? Why there is no called X label? Oh, sorry. We need to set the X label. God. Next, set Y label. Okay. Any other did I miss? Scatters. This is the plot, min and max. We have to set the title, set the X label, set the Y label. Nothing much. Then tight layout, show close. Okay. Next it will be bar plot alone, sort values. Okay, let's save it and we will restart the kernel again. Importing the utils, getting our data. Okay, now need to prepare the pipeline. We have already saved the model, so let's run it again. Okay, tight layout. I think I would have missed the underscore. Yes, culprit is here. Okay, but before that we'll see this. We have got one such good actual versus predicted predicted plot. Super scatter plot, actual temperature, and this is a predicted temperature, and setting the RMSE in the top corner, and this is our ideal line but not the fit line. These are our predictions. Okay, but we have got an error. Yeah, let's rerun. Okay, I'll restart the kernel. Get the data. Finally, this is a third try. Let's see. Yeah, everything is a success now. Okay, we have got the scatter plot, right? And pipeline object has no attribute coef. Okay, this is the one we need to inspect it, because we are working for linear regression. It should have the attribute coef. Let's notice what is happening. Our error, pipeline object has no attribute coef. Yes, we are not saving the raw linear regression model, we are saving the pipeline. So it will definitely don't have the coef directly. So what can we do? So we can okay, let's do one thing. On searching, we can see here that structured after pipeline implementation, our next step is gaining access to the coefficients for these features. Okay, this is built into the model object itself. So one way to get is through the built-in model object, that is dot named steps. Okay, then we might get the coef. Okay, let's try this solution. Where is it? Okay, I'll first, if my model has the attribute that is model dot named steps of the model itself, okay, comma, that is the coef underscore, okay, then I have to perform these but not right away. Okay, here also we are using this. So first two things we are going to get. Instead of getting xtest.columns, we have other methods too. Okay, so this is about getting coefficient. This is where, see, extracting a list of numeric feature names. Okay, for that they are getting get features name out. Then for coefficient they are using the coefficient. Okay, we need both feature names and the coefficient. Instead of having it from like this, we'll get feature names, coefficients. Okay, so same model dot named steps, this is a built-in. So our let's go to the pipeline. We have preprocessor and model. Okay, so what I can do is preprocessor. From the preprocessor I am going to get all the feature names out. So dot, what was that, get feature names out, get feature names out. Okay, then my coefficients, the same model dot named steps of the model itself. Okay, dot coef underscore. Fine, we have got the both. Now my feature will be instead of xtest columns I will fill it with feature names. Coefficients will be this thing. Okay, any other thing to change? If subplots, see, I missed this. Okay, putting a bar plot, setting a tight layout and show close. Okay, let's try this. Thanks to the Medium blog by David Hartzman, thank you so much. Then actually Medium is a very good platform to understand many logical things. So if you're interested in seeing video, go and see Josh Tarmer's StatQuest, and if you love reading, just go to Medium. I do both. Whenever I have a doubt, I'll jump to Medium, otherwise I'll go to the StatQuest to revise my fundamentals. That is my learning iteration 1. Then okay, now it is fine, I guess. Let's try to run it again. Let's restart the kernel. We hope there is no spelling mistakes. Hopefully all good. We got the model and now the evaluation. Okay. Oh, yes, superb. Yeah, see, this is the coefficient importance for the linear regression. See, here we have all models. This is the one-hot encoded weather features. See, 65, 53, okay, and everything is important. See the level of importance, that is, these are the negative way in a positive way. Okay, so this is our target variable, so it will definitely have highest correlation. So this is our coefficient importance plot. Then this is our scatter plot. Okay, really this is a very good job. Then what about the next thing, forecast. So now this was our detailed plan, right? no, this is not, this is evaluation metric thing. Okay, this was our detailed plan. We did this, and we have also saved the model, and we got evaluation and visualization done. So now it is we are moving towards the forecasting. So if this is okay, I would like to elaborate on the end day loop. Okay, let's get to the understanding of the iterations. So first I'll get the recent history from the raw data, that is in our weather DB. So from that, if my last date is 16th, then it will get 14 days plus 115 days recent history. Then during the first iteration, that is after getting the recent history, our loop starts, right? So in the first iteration, feature engineering should be done. Then with that feature engineering, we will predict the next day. Okay, with this next day prediction, we are creating a new row and adding it to the raw history itself. Okay, so this raw history will be added with the date 17, which was not previously. Now our last date is set to 17. Okay, then the second iteration goes. Then the feature engineering is done. The latest row will be fetched, the last row, then the prediction for the next day is done. So that will be 18.6. Then we are creating the new row. Okay, we are creating the new row. We are also storing the prediction in the prediction list. That is another thing. But we are creating a new row. Okay, then updating the raw history so that ours will have 16 and 17, right? Now our raw history will be updated with 18th prediction, then the last date is set to 18th, and now our history has 16, 17 and 18, and the second iteration, that is the third day. Okay, we did the 17th, the 18th, and now comes the 19th, the last day prediction. So for that we have the previous 2 days predictions updated, that is 17 and 18. So we have done it recursively. The forecast is being done recursively in an iterative manner, right? So our iteration 2 will have the same feature engineering. It will predict the next day, that is predict with the 18th features, we will be predicting the 19th day temperature. Now again creating a new row, we will be updating our raw history. So in addition to the 17, 18, we also add 19 to the raw history. Now our last date is set to 19. Our iteration should end because we are going to predict only 3 days. Okay, now our prediction list, we will add everything. We will add this prediction and this prediction to our prediction list. So it will have all the 3 days prediction, and our actual was 16, then these 3 will be predicted. So this is the final updation of raw history. So this prediction list along with the temperatures predicted will be our output. So this was the sketched out idea first. So we will just do the recursive forecasting. Okay, so the forecasting is the model should call the method from the helpers file, because this idea I thought was for the entire all the 5 models that we are going to see: linear, ridge, lasso, XG, and another one. So totally 5 models. So we'll be using this recursive forecasting model, implementing it in the helpers file and not in the model file. Okay, so let's start. I'll keep the model name as def forecast next 3 days. Okay, what if we keep n days? It is good, but with the given limited data set, that is for 10 years, and it will be reasonable only to predict 3 days. So let's keep it minimal. And model name, I'll be getting the model name, and okay, we'll just keep it as name as before. I also need to specify end days. Okay, now we already saw we will be updating the prediction list, right? So we are going to return this list, so that I will create an empty list, predictions list. Okay, now we got the name, so I load the model. table with the name. Now our first step is creating the recent history, right? So instead of, okay, we have the raw data but we don't have the recent history, right? Okay, so that we need recent history for about 15 days, let's say, because we are going to create lag features for 14 days. I think it is better to have 1 day extra. So instead of having that recent history here, let's have it in a new function, new method, that is get recent history. Okay, and one thing, we will set the max lag first. Okay, so okay, let it be constant. To set the max lag, I need to know the lag days, right? So in the feature engineering, linear, no, in Chennai, okay, where is the feature engineering? Okay, we got the lag days 1, 2, 3, 7 and 14. We have to keep the same thing. Okay, so lag days will be 1, 2, 3, 5, 7 and 14, right? So max will be max of the lag days. Okay, now what we are going to do is we are going to get 1 day extra, right? For the recent history we'll get 1 day. So that will be our logic, right? We have to send max lag plus 1. Okay, then this will be the history days. Okay, okay, okay. Well, where is our raw data? Our raw data is in our raw data. Where is our raw data? Yeah, this is here. So we have moved the raw data to our DB, right? So we have to establish our connection again, get a hold of that data, and we are going to use the query to retrieve data from that. Okay, I'll establish the connection. SQLite 3 dot connect. We have the DB path, right? So I'll mention this. Then after establishing the connection, no need of calling the raw DB. We have to create the query. Through that we will access the get raw data from DB. So our query will be, this is going to be a simple one. Okay, I have to select everything from my weather data. Okay, see. Okay. Oh, I saved it as weather date. Okay, no problem. Lots of spelling mistakes. From weather date. Okay. Now, okay, selected it from weather date. Good. Then I have to order by date. We'll be having the date column there because we need the last 15 recent history. So actually we need date. So that is why we are taking it from the raw data. Okay, so I will choose descending. We need just the history days, right? So I'll set the limit here. History days, it's not date. Okay, that is the end of the query. Okay, so history history df will be, I'll use the pandas read SQL function. I'll pass the query and the connection. Okay, so now we'll get the history df. Once it is done, we have to close the connection. Then okay, again we're ensuring that we have the same order. So history df is equal to history df dot, we'll sort values by, we have the column called date. Okay, now we have to ensure that our date is as per as of it is as date time, it is in date time format. So we will convert it and okay, and we will save it in the history df, the same column date, no need of creating new column. Now everything is set with date as date and not as any string or any other kind of value. Now I will return my history. Okay, okay, we will also reset the index, it will be better, drop equal to true. Next it will be forecasting data. Okay, we got the history, right? So we have to call that will be get history, recent history with max lag plus 1. Okay, that will be our history df. Okay, we start with history, we send the history, we return the history df, and we are getting it through history df. So there will be no kind of mismatch in the variables. Okay, there will be a very common understanding. So okay, we'll just print out for the purpose of understanding what data we are receiving. This recent history will be our history df. Okay, history df. Then our history df is done. What is the next step? Last date. We need to set the last date. So last date will be, since we have sorted it, we can get it from the recent history itself. In order to avoid any kind of mismatches, we are getting the date from the recent history. So I'll be getting the last row. So this is the last date that we have currently in our history. So I'll print the last date, and also it is good to mention last date in history. Okay, okay, fine. I'll mention last date. Okay. Next, what is it? We need to start the loop. Okay. Then the loop is based on the end days. I'll copy it. So for I in range of this, I will print as iteration starts. Okay, it is good to mention what iteration is. So iteration, let it be I. Okay. Now first, or more like we need to do the feature engineering, right? For that we need the feature engineering function method here. So do we have the feature engineering here? No, we have it in our primary thing. So what I'm going to do is I'll copy this and I will paste it here, so that in future we can use this feature engineering, because this is the actual feature engineering flow in which the model has been trained. So we have to use this. So this will be the same for every other thing, only the scaling difference and the pre-processing difference, but the feature engineering is going to be the same. We might use this for everything, every other forecast of all the other 4 models. Now once the iteration starts, we have to send the feature engineering with a df, like we have to call the feature engineering with the data frame, right? So we have the history data frame. So history df, so that is what we are going to feature engineer, because it has raw data with no engineered features. So our first step is feature engineering. So given that, we'll call the feature engineering with history df, right? And this is not the training, this is actually forecasting. So I need to make the training false, because we are having temp max next day, which is our our target variable. So I don't want the target variable now, so I'll keep training equal to true first. If training, then I need to do this, okay? Else I don't need this, okay? This is what. So we can also see feature engineering done, okay? Do we need to see that, or is it okay to display the column names? I think it is better to display the column names, okay, so that we can understand what kind of data, like how our data has been changed in the course, okay? Okay, then I'll keep training equal to false, okay? This will be our feature engineering. Then we can move on to once the feature engineering is done, we have to predict the thing, right? For that we need 16:6 data, that is our last date, last row, getting the latest row, okay? Now the latest row will be I will receive this as feature history df, better history df, so that it is featured, and it has been featured, like it's been in, like after feature engineering we have the variable name called feature history df. Okay, let's start, I'm wasting time. So the latest row will be feature history df dot tail of 1. I'm going to get the latest row. So I'm also going to print it, so that we the way we have like we printed last date, I'm going to print the last row in history, okay? That will be my latest row, okay? Next, one thing is, during the training we dropped our date column, right? During the training okay, we actually dropped the date column. So here also we are going to drop the date column, latest row dot drop of columns equal to date. If any error occurs, kindly ignore, okay? So this is the x input, it will be. Now it's time for prediction, okay? This will be to prediction. Now our next pred will be model dot predict of x input. This will be good. Then comes the next day, right? So next day will be the last date plus 1, okay? So I'll have pd dot time delta days equal to 1, which will add 1 day, okay? Now the prediction is done for the next day, okay? So that I will use this prediction list to append two things. one is our date, that will be next day. Okay, we have the prediction for the next day only. This prediction is for the next day. We have used the latest row to get the prediction of the next day. So my date will be next day, and formatting it strf time percentage y hyphen percentage month hyphen percentage d. This will be our date format. Then along with that, the second one is predicted temp. It's not changing the color. Okay, comma. That will be my next spread. But every value is like, we are going to round it off. What if we get more than 2 to 3 decimal places? So I will round it off to avoid unnecessary decimals to 2. Okay, I'll close this. Now our prediction list is fine. So create new, update the raw history. So now it is going to be 3rd. Okay, create new row. Okay, so our new row will have history df dot tail of 1 dot copy. So it will copy first the last date, that is I've mentioned here, right? 16, we will get the new row and we will append the 17. Okay, we will add the 17. So copy. Next okay, now we will append our we will add these two values to the new row. So new row will get date, and new row will get the temp max, which is our target. Okay, now this will be next day, and this will be next spread. Okay, the prediction. Okay, fine. So now update raw history. So that will be our 4th. Update raw history. So we have to take the history df and pd dot concatenate the history df with our new row. Okay, we need to ignore the index. So ignore index equal to true. Okay, now this will be our new row added to history, and let's see what our new row is. Okay, so this will be, now again we need to have the last 14 to 15 rows, so that our history updated with the new prediction. Okay, so I need to update it. So history df will be history df dot tail. From the last we are selecting till max lag plus 1. Okay, I will also reset the index because we are selecting a particular portion of our data frame. So true, capital T. Okay. Then now our history df at the end of iteration I. So I'll have the f string here. Okay, now it is done. Okay, now the next thing is what we did, this update raw history and max lag also we did. Okay, now we have to update the date for the next iteration, right? For that, our last date. So here we set our last date from the history. So, and we have updated our history. No, so the last date needs to get updated. So that will be last date, which is equal to the next day, because we have added the next day to the history. So it will be the next day finally water. I will print last date is set to last date. Okay, this will get us the last date, and I'll also, this is iteration starts, right? I'll end it here. Okay. Okay, so once this is done for all the three, we will be returning something. We have to return something, right? That will be my predictions list. Instead of sending the predictions list directly, I will send it as a data frame so that it will be useful, right? So okay, I need to get it out of the for loop. Okay, fine. Good. Okay, feature engineering, prediction over creating a new row. Okay, then finally updating the raw history. So I think everything should go well. Let's rerun this. Restarting the kernel. Running this to get utils. Okay. Loading the data. Okay. Now we need the forecasting, right? So, and our forecast model needs name and okay, days is given, so I'll just utils dot this one, and I'll send the name linear regression. Okay, so this will be the end. So this will be the results. We will print. Okay, let's see what happens. Then finally we will print. Okay, did we get any error? Wow, no error. Okay. First, this is a recent history. So we have 2 to 16, that is of today. Okay, the last date is 16th. So now iteration 0 starts. Our feature engineering done. So this will be our super good. We have got all the features, engineered features. Now the last row in history will be 16th. Okay, we have all the features. Now new row is added. Okay, the new row for the 17th is added, and our date weather, our temp max is this one, right? Okay, next temp min rainfall. Okay, these are all the things from the last row. Okay, we have copied it, right? So it will have the same. Next history df at the end of iteration 0, right? Okay, last date is set to 17th as expected. Then now iteration 0 ends, the iteration 1 starts, the same thing goes. Last row will be 17 and prediction will be 18, and it is added to the history. Now it is history at the end of iteration 1, last it is set to 18, fine. It ends, iteration 2 starts, feature engineering done, very good. So the last row will be 18th. This is a recursive forecasting. We did for 16, we had only 16, but we forecasted it for 17 and updated the history, so that with that we are again forecasting it. So this is a recursive forecasting until it ends. Okay, so now new row added is 19. Then the history df ends at iteration 2. So last it is set to 19. Okay, we have, I think we have got our desired results. Our forecast results will be superb. For 17 it is 29.95, 18 it is 30.1, 19 it is 30.4. We might expect this temperature for the next 3 days for the location Chennai. Okay, so this is fun working, and okay, So we needed a realistic 3-day prediction, right? We kept it short. So we did the model training, the evaluation, and saved the model also. For saving the model, we did the pipeline, right? That was the very important thing, and that's a good learning in this model, in this notebook. Then after saving it, we are evaluating it with the evaluation metrics. Through that, we got a very good plot of a scatter plot and a bar plot, where we saw the actual and predicted temperature and the ideal prediction line. So this is the coefficient importance. So this is where the importance of our features, also the engineered features, like in a kind of good visualization, we brought it into a bar chart. So for the forecast, this will be 3. So as our model expects the lag features, and that depends on previous real and predicted temperature, right? So recursive forecasting is best for linear regression. Recursive forecasting simulates like the real world behavior itself. It is by using only the predicted values to estimate the next day. Okay, linear regression does not understand time directly. So this recursive feature and the structure lets us like make us a step through time in manually. So not just 3, we can extend it till 5. It's a simple, explainable, and realistic way for predicting the maximum temperature of this particular location. So it is very good, and these 2 metrics are the ones we got for linear regression. So, and we got a good kind of inference from it. And we still have the other models. That will be Ridge, Lasso, Random Forest, and XGBoost. So let's have the next session on Ridge regression. So if possible, we'll cover the Lasso regression too. So hopefully this is our weather forecasting systems or extended idea for forecasting the next 3 days. And this is the deeper iterative recursive, like the recursive forecasting's iteration wise implementation. So these 4 and 5 things what we have implemented here. Fine. So this will be our last date will be our 5th. Okay, will be our end point. So this is where the next day is set. So forecasting, so we have made a DB connection, we got the raw history, and we got the last row. So with the trained model is separate, that is used for training. We got the raw model for to get the history and to again recalculate the features for that. Okay, in the same way what we did for the original to get the original trained model. Okay, so let's see in the next video. Thank you.